This is a continuation part of biostatistics, where previously we discussed about the measures of central tendency and measures of dispersion. Here we are to discuss about the normal distribution and the normal curve. So what is a normal distribution? First thing is, after we collect the data or the information from the large samples, we need to prepare a frequency distribution with small class intervals. So how do you do that? First thing which we have to do is we need to calculate the mean, and then we arrange the observations in order deviating towards the extremes from the mean on plus or minus side. And we see that maximum number of frequencies are around the middle, that is, they are clustered around the mean, and only few observations are at the extremes, decreasing smoothly on both the sides. That is, this normal distribution allows a tendency for the data to cluster around the central value. Now, what is the central value? The central value is the mean, which is located at the middle, and normally almost half of the observations lie above and half observations lie below the mean. So such type of distribution is called as a normal distribution or a Gaussian distribution. So this is about the normal distribution, where you see that the data is clustering around the central value, that is the mean, and this is located at the middle. Now let us see the arithmetic interpretation of the mean, so of the normal distribution. So what is this arithmetic interpretation? Generally, the standard deviation characterizes the spread of the normal distribution. That is, larger the standard deviation, more is the spread; smaller the standard deviation, less is the spread. And this normal distribution is a density curve, and we need to maintain the total area to be around 100%. Now here, within one standard deviation away, that is between -1 and +1, we have a total area of 68%. Similarly, within two standard deviations away from the mean, we have 95% of the total area, and three standard deviations away from the mean, it contains a total area of 99.7%. So that is the arithmetic interpretation of the normal distribution. Now let us see an example based on what we have learned. So here we have 95% of the students at the school, and they are between 1.1 meter and 1.7 meter tall. So from the information, we need to calculate the mean and standard deviation. Let us assume the data is normally distributed. So how do we calculate the mean? 1.1 and 1.7 add, and you divide by 2, which is 1.4. Now 95% means it is two standard deviations on either side. That is, you have a total of 4 standard deviations. So from what do you understand by 95% of the students? That means 95% of the children lie between these standard deviations. Now we need to calculate for one standard deviation. How do you do? Because the highest value is 1.7 and the lowest value is 1.1, that is, it ranges from 1.1 to 1.7. You 1.17 minus 1.1 divided by 4, by because there are 4 standard deviations and you want value for one standard deviation. When you calculate that, you get a value of around 0.15 meter. Now we know the mean is 1.4. So where should the mean lie? It should be in the center. So 1.4 is the center. Now you add 0.15 on the right side. So 1.4 plus 0.15 is 1.55 plus 0.15 is 1.7. You have got the highest value. Next, on the left side, you need to subtract. So 1.4 minus 0.15 is 1.25, minus 0.15 is 1.1. Now let us see the characteristics of a normal curve. So this normal curve is unimodal. That means you have a single peak, and it is symmetric. That means it can be cut into equal halves. Not only that, the first and the third quartiles are equidistant from the median, and here one important thing that must be noticed is that the mean, median and the mode, they coincide, and the curve approaches the horizontal axis but never reaches the horizontal axis. What do you mean by that? You can see in the picture, it looks as if it is meeting the horizontal axis, but that never happens. It continues to infinity so that we can go to as many standard deviations as we want, but it never approaches the horizontal axis. Now let us move to the basic concepts of the statistical inference. So what is this basic concept? So before starting any study or before starting any research, because we are trying to know about something, so before knowing something, we give an assumption statement that is known as hypothesis. So hypothesis in any assumption regarding the parameter or the nature of the probability behavior. So that is hypothesis. Next is null hypothesis. Null hypothesis is a hypothesis which reflects no change or no difference. That means it is a assumption, but that assumption reflects no change or no difference, and this null hypothesis is usually denoted by H naught. Now let us take an example such as fluoride does not have any effect on dental caries. Now this is a null hypothesis. We are trying to find out whether or not fluoride has an effect on dental caries. So before doing this study, we need to set a null hypothesis. So my null hypothesis statement would be fluoride does not has any effect on dental caries. So it does not reflect no change. So that is null hypothesis. The next thing is alternative hypothesis. Alternative hypothesis is any alternative assumption to null hypothesis. That is, it is a statement which is alternative to the null hypothesis. So what was our null hypothesis statement previously based on our example? That fluoride does not has effect on dental caries. Now, how should be our alternative hypothesis? Fluoride has a preventive effect on dental caries, because this fluoride has an effect on dental caries is an alternative assumption to null hypothesis. So this is denoted by H1. So we are clear about what is hypothesis, what is null hypothesis, and what is alternative hypothesis. Null hypothesis means which reflects no change or no difference, and it is denoted by H naught. Alternative means it is alternative assumption to null hypothesis, and this is denoted by H1. Now after we give this hypothesis, that is null hypothesis, next thing which we need to know is about p-value. What is p-value? P-value is the probability for the null hypothesis to be true. So the entire thing depends on this p-value only. The test which we perform, that tells us p-value, and based on this p-value we either reject or accept the null hypothesis. Now this can range from any value between 0 to 1. Now for example, if p-value is 0.1, what does that mean? If I repeat an experiment 100 times, 10 out of 100 times my null hypothesis will be true. Again, let us take one more value. P is 0.3. So if I repeat experiment 100 times, 30 out of 100 times my null hypothesis will be true. Okay, so that means 0.3. Now suppose if my p value is 0.05, that is, if I repeat an experiment 100 times, 5 out of 100 times my null hypothesis will be true. So this is what is p. Now before going to that, let us take an example. You have drug A and drug B, and you are performing a t-test based on which you get a p-value. First, suppose the p-value here is around 0.03. So what is the null hypothesis for this experiment? That drug A and drug B does not has any effect, and the p-value is 0.03. But when you have to know the level of significance, you need to decide the level of significance before starting the research, because we should consider the p-value significant or not. To know whether it is significant or not, we need to determine this before the research. Suppose if we determine it to be 0.05, here 0.03 is less than 0.05. When your p-value is less than the level of significance that you have set, then your null hypothesis is rejected. That is, you say that drug A and drug B does not have any effect. Okay, that is why it is a significant difference between drug A and drug B. Now next, suppose if you set the level of significance to be 0.01. Now the p-value 0.03 is greater than 0.01. That is, H naught is accepted. That means no significant difference between drug A and drug B. So what was our null hypothesis? No difference. Here it is greater than 0.01. Therefore, you are accepting. So, whenever p-value is greater than the level of significance, you accept the null hypothesis. When the p-value is less than level of significance, you reject the hypothesis. In the first one, when you are rejecting, it tells us there is a significant difference. Now, what is type 1 error? Type 1 error is nothing but you reject the null hypothesis when it is true. Type 2 error is when you accept the null hypothesis when it is false. So this is about the basic concepts. Now let us see the tests of significance. So what are these tests of significance? Tests of significance are nothing but these are the mathematical methods, or these are mathematical calculations by which we attain the probability or the relative frequency of an observed difference occurring by chance that is found. Now, why do we do this test of significance? After doing a research, we get the information. Based on that information, you perform this mathematical test. Based on the mathematical test only, you get a value, and that value interprets your exact result of the research. So before doing any research, as I told you, first thing which we need to do is we need to state a null hypothesis and an alternative hypothesis. After that, we draw conclusions based on the values of the p-value that we get after performing the tests, and whether the p-value is significant or not. Based on that, we reject or accept it. Now, first one is the test of significance of difference in proportions and means. Now, this test of significance of difference in the proportion and means are discussed under two categories. One is the Z test. Now, this Z test is performed whenever you have large samples. Large samples means more than 30 people in a sample. And T test is performed whenever you have small samples, that is less than 30. This T test again has unpaired T test and paired T test. We will discuss this in detail. So, first one is standard error of mean. So, what do you mean by standard error of mean? It quantifies the precision of the mean. What do you mean by quantifying the precision of the mean? It is nothing but it tells us a measure of how far your sample mean is likely to be from the true mean of the population. So what is this? Because here you are only taking a sample from the population. You are not taking the entire population and doing your study. You are only taking the sample from the population and you are doing a study. So the mean you get is also the sample's mean. It is not the population mean. But you are attributing this sample mean to the entire population. But you need to know whether it is true or not. So this standard error of mean gives us the measure as to how far your sample mean is likely to be true from the population mean. Now, similarly, you get this in the form of proportion. The standard error of proportion is it quantifies the precision of the proportion. That is, it is a measure of how far your sample proportion is likely to be from the true proportion of the population. So, the population your sample population is compared to the original population, where P is the proportion of the males, Q is the proportion of the females, for example, two different rooms, and N is the sample size. Now, the next thing that we have is the standard error of difference between two means. When does the standard error of difference between two means occur? When you have two results, that is when two groups are present. So you get one result from one group and the other result from the other group. That means you have two groups. That one group would be the control group and the other group would be the experimental group. So in this we calculate the difference between the standard error of means between these two groups. Now for that, what would be the equation? The standard error of difference between two means would be square root of the standard deviation of the sample 1 divided by the sample size of the first group plus standard deviation of the second one divided by the sample size of the two. That is, sigma is denoted by standard deviation and n is denoted by the sample size respectively for two groups. Similarly, how we have seen the standard error of difference between two means, we even have the standard error of difference between two proportions. Here, instead of means, we have to test the significant difference between the two proportions. Okay, so here also you have two groups because you are calculating the difference. No, so one is the control group and one is the experiment group, but proportions means again suppose two quantities, now males and females. So we calculate the standard error of proportion P1 P2 is given by square root of P1 Q1 divided by N1 plus P2 Q2 divided by N2, where P1 means variable 1 divided by the sample size 2, Q1 means 1 minus P1 and N1 means sample size for the first proportion. Q1 would be variable 2 divided by N2, Q2 would be 1 minus P2 and N2 would be the sample size for second proportion. Now the next thing is the t-test. What is this t-test? As I told you, this t-test is performed whenever you have a small sample size. Okay, so this is given by WS Gauss set, and this t-test is again of two types, that is the unpaired t-test and the paired t-test. Now let us see the criteria. In order to do a t-test, we need to have a continuous quantitative data, and it should be a random sample, and normally distribution in the data must be seen and the sample size should be less than 30. Now first let us see the unpaired t-test. When do you do unpaired t-test? When you have two different groups, that is, suppose if we need to calculate the dental caries of men with that of the women. So men and women are two separate groups. Then you do this unpaired t-test, and this is the formula. So this is applied to two independent samples and checking significant difference between the means. Now next is the paired t-test. Here also you have two things, but the same group is tested twice. When the same group is tested twice, you get two times the data. That is the reason it is called as paired t-test. You have two informations, but it is from the same group, that is before and after. Suppose if we need to calculate the DMFT before using the fluoride mouthwash and after using the fluoride mouthwash for the same group. So the information that you get before that mean would be the one data, and the information that you get after that would be the second, that is the paired t-test, and you calculate with that formula. So here D means the difference between the x1 and x2, that is the before and after, and SD means the standard deviation for the difference, whereas N is the sample size. So this is about the t-test, under which we have the paired t-test and the unpaired t-test. Thank you.